So let's start our third part. Functions of inductors. Inductors can be basically used for two functions: for controlling the signals and for storing the energy. So what does it mean by controlling the signals? Coils in an inductor can be used to store energy. The function of the inductor depends upon the frequency of the current passing through it. That is, for higher frequency signals will pass less easily, and vice versa, means lower frequency signal can pass easily. This function tells that it blocks AC current and passes DC current. Hence, it can be used to block AC signals. Inductors can be used along with capacitors to form a LC filter. So controlling signals mean controlling the functionality, you can say. How? If we use the capacitor with the inductors, it will be in the form of filters. And why we use filters? To control the in signal processing, we use filters to control the different type of frequency signals. But in electronics, we will use filters to filter or control different type of current, AC current or DC current. Mostly the function of that controlling is that mostly it blocks the AC current. You will find this in AC current, and DC current will pass through it. Hence, due to some modification, filters or other things, it can also block the AC current. So this is called the controlling signal. You can also say it is the controlling of the current, because if in electronics we are talking about filters, then filter means we are trying to control something. It can be frequency, it can be type of current, it can be flow of current, anything. What is storing energy? Inductor stores energy in the form of magnetic, that we already, because it is a passive device and it store energy in the form of magnetic field, and its property is of storing this energy is called inductance. Coil can store electrical energy in the form of magnetic energy, using the property that an electric current flowing through a coil produce a magnetic field. This we know that whenever the current flow through a coil or anything wire, it will form a magnetic field around it, which in turn produce a electric current. As I told you before, the current is not that particles are flowing into the material or a wire. It's just the transferring of energy from one particle to another, and an electric field or magnetic field is around it due to this transfer of charge, and that is called electricity or electric current. In other words, coils offer a means of storing energy on the basis of, so storing energy means it can save energy in the form of magnetic energy. So now we talk about the inductance in series. Inductor and capacitors are almost same in series and parallel. So you will find the numericals will be also same. Only difference will be the symbol of resistor and a inductor. But capacitor have a different properties in series and parallel, which we already studied. So if the inductor is in series, if we connect n inductance in the series, the combined effect of all inductance is equal to the sum of individual. It is same as the resistor. If there are two or three more than two inductors are and they are connected in the series, the combined effect of all the inductance will be the total sum of all inductors in the circuit. We take the first example. There are two inductors. Here we have two inductors, and we have to find the total effect of this inductor. So the value of the inductors are 1 and 1 both. H means Henry, it is always measured in Henry. So we will just combine these two, because in series, inductors are just simply add. So the combined effect will be 2. It is the same example if we have 3 inductors, so they all are in series connected with the in the series 4, 3 and 1. So all the combine of sum of all the inductance will be equal to the combined effect of an inductor. So what if the inductor is in parallel? We connect an inductors in parallel. The reciprocal of combined effect of all these inductors is equal to the sum of reciprocal of individual inductors. It is the same formula we used in resistor. Let's directly do the example. We have an example of two inductors that are in parallel to each other and the values are both 8. So we will do the reciprocal. 8 into 8 divided by 8 plus 8. So the combined effect of these two inductors in parallel will be 4. In example 2, now we have 3 inductors and all 3 are connected in parallel to each other. So we will start one by one. First we will take these two inductors 6 and 3 and we will take the reciprocal 6 into 3 divided by 6 plus 3. So the combined effect will be 2 and now 2 ohm will be solved with the 4 value. So 2 into 4 divided by 2 plus 4, the combined effect of all these inductors are 1.33. Now let's take the third example. Example 3 are having 5 inductors and some are in series with each other and others are in parallel. So let's start one by one. First we will take the 6 and 3. So 6 and 3 both are in parallel to each other. So 6 into 3 divided by 6 plus 3, the combined effect will be 2. Now these two inductors are not parallel to each other, they are in series. So what we do in series, we just combine the inductor values. Now in remaining 3 conductors, 2 are in parallel to each other, that are these both having 4 values. So how we will solve the parallel? 4 into 4 divided by 4 plus 4. Now the last remaining two inductors will be value of 2 and 1, and these both are in series with each other. So the final effect of inductor or value is 3. So now today we complete our inductor. Before that we did resistor and capacitor. In series and parallel, the properties of the resistor and inductors are almost same, but the capacitor have a different procedure of solving in series and parallel. So such type of examples you can do from your book, from internet, from notes, and in exam you can also get the numericals, not only with the inductor or resistance, but there will be also a combined, there will be few inductors, there will be few resistors, but you have to combine them and solve and get the values. So thank you for today's lecture.